Welcome to the lair of the Batty Boffin.
Hi there Batty fans, a little bit more about respiration. Now in earlier videos we talked about respiration as being this equation here in words. Glucose plus oxygen, glucose that's going around your bloodstream right at the moment, plus oxygen that you breathe in via respiration, which is the chemical reaction that breaks down the glucose and turns it into carbon dioxide and water. And because you're breaking down a big molecule, you are releasing energy. So those are black wiggly lines showing that energy being released. And that is going on in every cell of your body right this very instant with some wonderful little organelles called mitochondria. Now, a lot of people think that the animals, like us, do this glucose plus oxygen, respiration to breathe out the carbon dioxide and water, and the plants do the opposite. The water plus carbon dioxide via photosynthesis, which is the same reaction just going the opposite way, photosynthesis to oxygen and glucose. Animals do that one, plants do that one. That's not quite true. Every living thing respires all the time, and that includes plants. Now, animals don't photosynthesize, okay? I mean, however much I sit outside in the sun and paint myself green, I am not going to generate my own glucose. It just won't happen. Plants can photosynthesize, but they also respire. They're doing both at the same time, plants are. Generally what happens is, when they're in bright sunshine, they photosynthesize more than they respire. So they're kind of doing a net output of oxygen. However, at night, when it's dark, the animals are still respiring. I mean, they've still got to grow bits of leaf and bits of apple or whatever. So plants are respiring all the time. During the day, they photosynthesize more, so they've got a net output of oxygen and glucose. During the night, they will actually be using up some of their own glucose and the oxygen and giving out carbon dioxide and water. So actually, during the day, plants will be giving out oxygen. During the night, plants will be giving out carbon dioxide and water, just the same as you do. It's just that we don't tend to notice the respiration one quite so much in plants. We tend to kind of focus on the photosynthesis. But plants are actually doing both all the time. Well, they're doing photosynthesis when it's light, they're doing respiration all the time. Now, we looked at this word equation in earlier ones, but this time we're going to put some of the formulas in. Now, I've got some formulas up here. Don't worry about those top ones, they might look a bit, but they break down quite nice and easily. At the top we've got glucose, C6H12O6. So that means it's comprised of 6 carbon atoms, 12 hydrogen atoms and 6 oxygen atoms, all kind of stuck together in a rather clever arrangement. Lactic acid we'll talk about in a later video. Here we've got water, I'm sure you're familiar with that one, carbon dioxide and oxygen. Oxygen hangs around in two oxygen atoms stuck together, O2. I'm not advertising there, okay, other phone companies are available. So those are our formulas. We're going to be using glucose, water, carbon dioxide and oxygen. So what we're going to do is at the side of each of these, glucose, oxygen, carbon dioxide and water, we're going to write the formulas, and then we're going to do what's called balancing the equation, okay? Matter is neither created nor destroyed, so everything you start with has got to come out the end. So if you start, for example, with 6 carbons, you've got to have 6 carbons coming out the end, and you can kind of fiddle with the relative proportions to work it out. So I'm going to start off by writing these down, and I'm probably going to speed up this bit of the video because it looks cool. So I'm going to write down the formulas for these just down here, okay? Right. Now we've got to balance this formula. It can go both ways. Formulas normally start with the ingredients and end up with the product, but this one actually can go that way or that way, so it doesn't matter. So, having a look at this, we've got 6 carbons up here. Down here we've only got 1 carbon, so obviously we need to produce some more CO2s. It's not just one molecule of CO2, we've got to have extras here. Also, we've got 12 hydrogen atoms up there. We've only got 2 down here, so obviously we're going to have more molecules of water as well, not just 1 molecule of water. Oxygens, well, we've got 6 there, plus another 2, that's 8 so far up here, and we're only using up 6 down there, so 3 down there, so really it's not balanced at all. So time for you to pause the video and see if you can work out how many molecules of oxygen, how many molecules of these you will need so that it all balances. Okay, have a go with that now. Right, let's have a start with this. I'm going to start off with 1 molecule of glucose. You don't have to put the 1 in if it's just 1, but I'm going to. Right, in order to get those carbons, there's 6 there, and that's the only product that's got carbon in it. So 6 carbons, I've got to have 6 CO2s in order to use up all my carbons. Okay, now the hydrogens, again we can look at that. There's only one place I've got hydrogens there, and only one place is hydrogen there. That's got 1 times 12, so 12 hydrogen atoms there. That uses 2 for every molecule of water. So if I put 6 molecules of water, I've used up 12 H's. Yeah, so my H's are balanced. Now the oxygens, that's a bit more tricky because it's in 2 places there and it's in 2 places down here. But let's see what we've got. 1 lot of 6, so that's 6 of them so far. 7, 8. 8. Down here I've got 6 molecules of CO2. That's using 12, 6 times 2, so that's 12 oxygens there, plus another 6 oxygens there, so it's 18 and 8. No, that doesn't balance at all. I don't really want to fiddle around with that one because that's got my carbons and my hydrogens right, so I'm going to fiddle around with that one. So I need 18 oxygens. I've already got 6 there, so I need another 12. Well, if I put a 6 in front of here, 6 times 2, that makes an extra 12. So there altogether, that's 1 times 6, that's 6, and another 12, 18 oxygens at the top, and 18 oxygens at the bottom. So there is your balanced chemical equation that's the same as this one in words. Glucose plus oxygen gives you carbon dioxide and water. So we break up 1 molecule of glucose into actually 12 tiny molecules. It's quite efficient. You know, we break that up a lot, and remember, every time we're breaking bonds we are releasing energy. So that actually is quite a lot of energy being released there. Of course, that's when we're breaking it up. That's respiration. The other way round is photosynthesis. So that's plants taking 6 molecules of carbon dioxide, 6 molecules of water. They add energy from the sun, and they breathe out 6 molecules of oxygen, for which we are very grateful, and create 1 molecule of glucose, which they store away in either their roots if they're carrots, or their fruit if they're strawberries, or anywhere else they happen to think of it really, which we then eat. So there you've got your word equation and your chemical formula equation for respiration and photosynthesis. It works both the same way. Now we're going to come back in the next video and we're going to talk about 2 different types of respiration. I'll see you next time, Batty fans.
Mwahaha! Mwahaha! Mwahaha!